I'm going to go through the first quiz from derivatives because the student asked me to, and that's definitely what I will do. If you ask, I will just jump on and do whatever instructional videos I can. Good to see that more people are joining in. Tomorrow's your first due date, and I will enter any grade that will improve your current class grade. So that's a good opportunity to retake the unit exams until you get the score that you're going to need in order to improve your grade. So what I'm going to do is I'm just going to go through the questions that were commonly missed from Khan Academy, and I'll show you, we'll do this often, hopefully. On the left side of the screen, it tells me that on the first attempt, question number 10 was missed by 3 people, and one person got it right on the first attempt. And so you see going down the line here on the left side of the screen, I'm going to go through a few of these questions and see if it kind of jogs your memory on how to do these. Most of these questions have to do with the mean value theorem. And so the first question that was missed by 3 people asks, let g of x be given as the root of 5x minus 1, and they want you to find the value of c. 3 people answered 2.25. and only 1 person got 4.25. So let's see how those numbers come up in order to solve this problem. So I am going to get into, in class it took me a while to get back and forth to my Surface Pro to my camera, and it kind of does the same thing here. But anyway, here we go. So the mean value theorem has a few conditions that in order to use the mean value theorem, you have to have a function that's continuous on the closed interval and differentiable on the open. And once that's true, that the derivative at some point in the interval from A to B must equal the average rate of change. So there it's like 2 sides of the equation. On one side, you're going to find the derivative, and then the other side, you're actually going to use the given function and basically use like the slope formula, right? The change in y and the change in x. So I'm going to do this side first with a given equation of g of x. And so what I'm finding is g of, let me go back to the interval here. It was between 1 and 10. So g of 10 minus g of 1 all over 10 minus 1. And when I sub in 10, I'm going to actually sub it into the given equation. And so that's going to give me 50, take away 1, and that's root 49, which is 7. I also need to know what the value of g of 1 is. Subbing in 1 is going to have 5 minus 1 under the root. That's going to give me root 4, and that's going to be 2. And so the average rate of change, the value of the square root function goes from 2 to 7, right? So the change in the y's are 5 when the change in x is 9. And so 5 over 9 is what the right side of the equation is going to be if I'm trying to solve for this c. This is the average rate of change over the interval. But what they want to know is when the derivative is actually equal to that. And so on the left side of this equation, I'm going to find the derivative by using my derivative rules. So 5x minus 1, another way to view that is 5x minus 1 to the 1/2 power. Now that I know what the power is, I can use my power rule. So 1/2 of 5x minus 1 to the negative 1/2. And don't forget the chain rule, that this is the u, so I have to multiply times the du. And cleaning that up so that it's easier to play with once I get it into an equation. I try to solve for something. These 2 things are the same, right? They're just written differently. One of them with a power, one of them with the root. So this is the derivative. This is the average rate of change. And what we want to do is let those 2 values equal and then solve for x. So now some people give me 2.25. I'm thinking maybe they just did 9 divided by 5, but that, first of all, it's reciprocal, but then also that's just the average rate of change. That's not the x value for which, if I sub it into the derivative, it's going to equal 5 over 9. So what you're doing here is actually solving for an x value that should be between 1 and 10. That if I were to substitute x in to the left side here, which is the derivative formula, that it would give you 5 over 9. So that's what I'm doing. Now I'm trying to solve, and I want to clean up whatever I can. If I have 5 in the numerator, 5 divided on each side is just going to give me a 1. The next thing I'm going to do is I'm going to use my cross product. And then so what I'm actually going to be solving is this equation right there. And I'm trying to isolate the x. So I'm going to try to isolate the root first, and then once I get that root isolated, I will raise both sides to the second power, and then I'll solve for x just by adding 1. That's 4 over 4, so it's 85 over 4 equals 5x. Then I'll divide both sides by 5. Final answer, 85 divided by 20, and that should give you the answer that was the correct answer. So I'll go ahead and run through one more of those. But again, that was how you wanted to find the value of C, not find the average rate of change. So let me take you through another question that was also commonly missed. And again, it takes me a quick little while to get to sharing these screens. So the second question is very similar. That was also commonly missed. It was the square root of 2x plus 1. Again, take the derivative of that. So that'd be 2 over 2 root 2x plus 1. And then you want to let it equal the average rate by subbing in 12 into the square root, subbing in 4 into the square root. And then that looks like it would be 5 minus 3. You know, again, I'll do another one right now. I'm just doing that out loud, but this one looks very similar. Now, when you get to the third question that was commonly missed, it takes you through a given information. You have table values. Leo's trying to do a formal justification. So in order to formally apply theorem, there's an if and a then to a theorem, and the then part's only true if the if part's true. So in order to use this theorem, you have to make sure that you have a function that's continuous on a closed interval and differentiable on the open. And so what you see Leo doing is finding the average rate of change. The average rate of change is 1. And what he's like, according to the mean value theorem, that you have to have, well, you don't have to unless the function is differentiable and continuous. So that was the correct answers that you see over here on the right side of the screen. He had to mention that it was differentiable in order to use the mean value theorem. You can't say according to the mean value theorem, this is true unless you can apply the conditions. Question number 6 is polynomial. So let me go ahead and jump into that one. So again, given that f of x is x to the third minus 6x squared plus 12x, and I'm looking at the interval from 0 to 3, now the correct answer is going to be 1. I can see that on the right side of the screen. But what I'm going to do is take you through what the theorem is guaranteeing for us here. So if I wanted to know what the average rate of change was, I would sub in a 3. So f of 3, 3 to the third is 27 minus 6 times 9 plus 36. Right, that's going to give you 63, take away 63, so that's 0. So that means that f of 3 minus f of 0 all over 3 minus 0 is going to be 0, subtract, and then I can also see that if I sub in a 0, I'm going to get 0 to the third minus 6 times 0 squared plus 12 times 0. Right, and basically I'm messy here because hopefully you could tell that I'm just going to get a 0 again. So when I'm working out the average rate of change, that's just going to give me 0 over 3, which is 0. When I find the derivative, however, f prime of x is going to be 3x squared minus 12x plus 12, and that's me using the power rule. And then what the mean value theorem guarantees is that these two things are going to have a value of x. When I let these two values equal each other and I solve for x, I should get a number between 0 and 3. Now I might end up getting 2. That means that the average rate is equal. That means that the derivative is equal to 0 more than one place. But I'm only wanting to prove it for the interval that they're asking. So anyhow, I'm going to move forward. So 3x squared minus 12x plus 12. I see right now that there's a common factor of 3. And then I'm letting this equal 0. So divide both sides by 3. And then you'll just get that this is equal to 0. and then two numbers that multiply to make 4 that add up to make sorry, that add up to make 4 are going to be -2 and -2. And so I'm getting the answer is 2, but I thought the answer was 1. So, oh, such a great ending. Hopefully you forgive me as you always did. And then let me take us back to Khan Academy and we'll see what I did wrong. So 3x squared minus 12x plus 12, I divided by 3, I got that. And then when I subbed in the 3, it's 27 minus 6 times 9 is 54. That's what I did wrong. I was going too fast. So 27 minus 54 plus 36, that's 63 minus 54, that's 9 divided by 3. I'm sorry, I'm just talking. In a quick second, I'll hopefully clean this up sort of nicely here. So let me take you back to my scratch work over here. Again, I apologize. Hopefully you forgive me. As I was going too quickly, subbing in a 3 does not give me a 0. This is not 63 minus 63, math teacher. It is 63 minus a 54, which is 9. And so this sucker right here is 9 over 3. And then this right here, if I had a 3 on the outside, now I want it to equal 3. Oh, Lord have mercy. Hopefully you forgive all the quadratic errors. At this point, I could have subtracted the 3 divided by 3. Why not, right? If you're in it for this long, we work it all the way out. So at this point, if I would have let the derivative equal the correct average rate of change, I would have 3x squared minus 12x plus 3 equals 0. And plus 9 equals 0. Then I'm going to factor out a 3. And that's going to give me two numbers that multiply to make 3, but add up to make -4. This is the correct factorization. So there are actually two different values of x for which the derivative is equal to 3. Now, there was a value of x where the derivative is equal to 0, but that's not the one I was looking for. Correct answer is 1 to this problem. And hopefully you miss all the mistakes that I made in class and forgive all of them. And please, please, please keep working. Keep asking me questions. I'll talk to you again soon, I hope. Bye-bye now.